Today we're going to go over how to factor monomials and polynomials using different factoring methods. So we're going to start with factoring monomials. A monomial means that we just have one singular term. Uh, and so with that term, our term can either be, it can just be a number itself, or it can be a number and letter combination. So let's take a look at this first problem. It says the rectangle below has an area of 144x to the fourth square meters and a width of 12. And we want to find what the length is. And to do that, the area is just length times width. And so we have to ask ourselves, what times 12x gives us 144x to the fourth? Well, if we look at the x's first, x times x cubed is going to give us x to the fourth. So we know x cubed is one of our terms. Next, we want to figure out how do we get 144? 12 times, and that would just be 12 again, would give us 144. And so that's how we solve these when we're given an area formula. The next problem is going to ask us who factored this correctly. It gives us two people and it shows what their work is, and it wants to know, did they both get it right? Did they both get it wrong? Did only one of them get the answer right? So we're basically looking at 14y cubed for both of these people. We want to figure out these two terms. If we multiply them together, will they give us 14y cubed? 7y squared times 2y is 7 times 2 is 14. Y squared times y is y cubed. So this person factored that correctly. 10y times 4y squared, that would be 40y cubed. So this person was not correct. So only this person factored that correctly. Okay, now we're going to look at monomial factors. It says figure out what makes the equation true. Uh, we're going to solve this. We can solve this one of two ways. So you can solve it algebraically, or you could solve it with just guess and check. So let's look at algebraically first. So if we want to solve this for C, we want to figure out what times 4x squared equals 12x to the fifth. We can just solve this with algebra and divide by 4x squared on both sides. So we get 3x x to the fifth minus x squared is x cubed. So that's what C is, 3x cubed. And we can check our answer. Does 4x squared times 3x cubed equal 12x to the fifth? 4 times 3 is 12. X squared times x cubed is x to the fifth. So C is going to be 3x cubed. Okay, the next one looks like next one here is an area one again. I'm going to skip that one because I'd like us to go to one other type of question here. Let's see here. Right. Let's look at one of these with negatives. So, as always, it's important to know what our signs are. And this says negative 35x to the sixth equals negative 5x squared times b. So what times negative 5x squared will give us negative 35x to the sixth? Well, negative 5 times 7 is equal to negative 35. So there's our coefficient. X squared times what is x to the sixth? That's x to the fourth. We add our exponents when we're multiplying. We subtract them when we're dividing. And we could solve it the other algebraic way as well. And you don't have to use algebra for for this specifically, but I'm just showing you that these are the steps that we would do algebraically for this. So again, negative 35 divided by negative 5 is 7. X to the 6th over x squared is x to the 4th. And those would cancel out, and we would get that for B. Okay, so that's factoring monomials. Um, Next, we want to look at the greatest common factor. So they're going to tell us three different values, and they're going to be number letter combinations. So it says, what's the greatest common factor of these three values? If we look at the z's, um, we're going to factor out the greatest z value first. I think that's always easiest anyway. So this is z to the 1 or just z. We can factor out a z from all three of these. Now we want to look at what's the greatest coefficient or number that we can factor out. Well, we can also factor out, looks like 54 divided by 18. Looks like we can divide that by 18 also. 36 divided by 18 is 2. 18 divided by 18 is 1. So it looks like we can factor out an 18. So if we divide by 18z for all of these, this is how we would check our work. This is 3z squared is left over. Divide that by 18, we just get 1. This one divide by 18z. This would be 2z. And I'm just putting dashes on the z's, make it a little bit easier to see that it's a z there. So it looks like these are all prime numbers, and we can't factor that any further. So this is our greatest common factor, 18z. Okay, let's see if maybe there's one more problem type on here. There might not be. Let me see here. I think these are all pretty much the same. There can be negatives on some of these. Let's just try maybe one more of these. Let's see if I can find one that's a little tougher. Here we go. This one looks a little bit more challenging. So again, when we look at these for the greatest common factor, we want to look at the variable amount first and then the coefficient. So uh, looking at our n's, it looks like we can factor out an n squared. That's our greatest common factor. And then for the coefficients, it looks like 15 is the biggest number we can divide by. So if we divide this by 15n squared, we get n cubed. If we divide that by 15n squared, we get 2n. If we divide that by 15n squared, we would get 3. Okay, and then when we look at these values, we can examine and see if we can factor any further. So if I picked like 5n squared, then if we had more that we could divide by, we would do that again. And we would figure out, well, what was the biggest number or the greatest number that we could factor that by? So this is 15n squared. Okay. Here's the next one. The next part is very similar to the last problem type that we did, except we're going to rewrite this now as an equivalent statement. So if we look at 9b to the 8th and 24b cubed, we want to figure out what's the greatest b term we can factor out. Well, we can factor out a b cubed. That's the biggest b term there. And it looks like 3 is going to be our greatest factor for the coefficient. Now, when we write what's left over, we write it in parentheses now. So 9b to the 8th, 3b cubed times what is 9b to the power of 8? That's going to be 3b to the 5th plus 24b cubed. 3b cubed times what is 24b cubed? That's going to be 8. So we're rewriting this like we're rewriting this like a new expression. So 3b cubed, 3b to the fifth plus 8 times 3b to the fifth plus 8. Okay. And then here's just a slightly different format of that. All right, so it says the width of this rectangle is equal to the greatest common monomial factor. So this is going to be our greatest common factor. That number goes there, and then we write what's left over on the length. So the same basic idea as the last problem we did, um, but it's just in a different format. So this would be like everything equals 14x to the fourth plus 6x squared. So our greatest common factor for our variable terms is x squared. And it looks like we can just factor out a 2 for the coefficient. So if we divide that, now 14x to the fourth divided by 2x squared is going to be 7x squared. 6x squared divided by 2x squared is just going to be 3. So if we rewrote it as an expression like the last problem, it would be like that. But it just wants us to write the width and the length individually for these. Okay. Let's look at one now that where we have three terms. And this is again very similar to the last one that we did or a couple of problems ago, except now it wants us to write an equivalent statement, and we also have to focus on looking at the correct sign. So our greatest common variable term that we can factor out is a k cubed. And looks like I'm going to say 11 is our greatest coefficient that we can factor out. That would leave us with 4k squared minus 6k plus 7. And again, we can check this part and see if there's anything more that we could factor out. If there was anything more that we could factor out, we would put it here and multiply it by this amount that we've already factored out. But there isn't anything else we can factor. The greatest number or value that we can divide all three of these new values by is now just 1. So we don't really write the 1 there because that doesn't change our 11k cubed answer. So that's going to be our final answer for how we write an equivalent statement um, for factoring the greatest common factor with three terms. And I'm just checking the answer here. Okay. All right. So that's greatest common factor with 2 and 3 terms. Now we're going to look at factoring higher degree polynomials. Now, there's a couple of different methods for factoring higher degree polynomials. One of those methods is called factoring by grouping. And factoring by grouping allows us to make two groups with 4 terms that are given to us. I'm going to rewrite this out because we have to write the parentheses in a slightly different place. So when we have 4 terms, the first thing we want to check for is if we can do factor by grouping. So we group the first binomial pair, and then we group the second binomial pair. And it's very important that we put a plus between those. If we don't put a plus between them, that makes it a false statement because we're not multiplying these together. We're still just adding these. And all I'm saying is plus -5. That's the same thing as -5, or plus -5x is the same thing as -5x. Now we're going to take out our greatest common factor from the first binomial and from the second binomial. So we're going to factor out x squared from the first binomial. This is x squared, and this is x plus 7. Now, when we factor by grouping, we want a factor pair there and there, and we want it to be the same amount. So I'm going to write x plus 7 here. Now we're going to check over here what makes this true. So what times x is negative 5x? That's negative 5. And if we did negative 5 times, so that's negative 5x. If we did negative 5 times 7, do we get negative 35? Yes, we do. So now that we have these two groups, we merge them together. This is x plus 7. And then we write these two other parts on the outside here, x squared minus 5. And that's our final answer for factoring this. Now we are multiplying this for our final answer. If later on we want to know what the answer is for x, or it says solve for x, we can go one step further and we set each of these equal to 0 and solve for x. But for here, we're just factoring. So that's how we factor by grouping. We factor them into two different groups, find the greatest common factor, combine these factor pairs into a single factor pair there. Okay, I'm just going to check my answer here. Okay. Next, we're going to look at a two-part problem where we have to find the greatest common factor and where we're going to use something called the AC factoring method. And the AC factoring method should be reviewed for, I think, for many people. But if it isn't, that's all right. So the first thing we're going to do here, we have 3 terms. We don't have 4 terms. So let's see if we can factor out the greatest common factor and see if that helps us. So it looks like everything's divisible by 7x cubed. So we factor out a 7x cubed. We're going to write what's left over, 2x squared minus 3x plus 2. Okay, so this is closer to our final answer, but it is not our final answer altogether. What we ultimately want to do is we want to split this negative 3x into 2 different pieces so that now we have 4 terms, just like in our last problem, and we can factor by grouping. In order to split that into 2 different pieces, we use what's called the AC method. So this part is a quadratic. On a graph, it looks like something like this. And on that quadratic, when we factor, when we set it equal to 0 and we solve, we get the answer of where it crosses on the x-axis. So that's kind of an overview of what this is. Now, when we have a quadratic, the basic formula of a quadratic is y equals ax squared plus bx plus c. So for this section here, we're going to kind of ignore the 7x cubed until the very end. So for this section here, a is equal to 2, b is equal to negative 3, and c is also equal to 2. Now, when we want to figure out how to separate this into 2 different numbers, we use what's called, or I call this the AC factoring method or the AC method. So we find out what is a times c, 2 times 2. That's just equal to 4. Okay, so a times c is 4. Now we want to figure out what's all the ways we can multiply to get 4. And we're going to write a list. 1 times 4, 2 times 2, and also the negatives. -1 times -4, -2 times -2. And that's all the ways to get 4. Now, when a times c is a bigger number, we have a much larger list. But here we have something that's a little more simplified. Now, sometimes we can't factor this, and we have to use the quadratic formula, and I'm just going to check to see if we have to do that in just a second here. Just one moment here. I think I made a slight mistake. That's not how we factor this part. This is actually just x squared there. A is equal to 1 here. I thought something seemed a little strange here. So let's back up just a step here. So let's recheck this now. 7x cubed times x squared is 7x to the fifth. I wrote a 2 there. I don't know why I did that. I think maybe I was looking too far ahead at the 14. 7x cubed times -3x is -21x to the fourth. 7x cubed times 2 is 14x squared, x cubed, excuse me. So a times c now is equal to 2. This makes our list even easier. 1 times 2 is 2. -1 times -2 is also 2. Now we want to figure out which group, this group or this group, if we add those together, equals b, which equals -3. Well, it's going to be this group equals -3. So we're going to separate this -3 into a -x and a -2x. And then we're going to write the rest of this. So all I did that I changed from earlier was this was a 2, but really it was supposed to be a 1. Our AC is now 2 instead of 4. We're still breaking up this -3x into two different pieces. -1 and -2, -x and -2x. Okay, now we have 4 terms and we can factor this by grouping. I'm going to put a bracket here to show that we're multiplying all of this by 7x cubed. We're just going to hang on to the 7x cubed and not do anything with that just yet. But we are going to group these like this and put a plus between them. That's really important. We're not multiplying these. This has to be -x plus -2x equals -3x. So plus goes between them. Now we find the greatest common factor from this group and then from this group as well. So we write 7x cubed, and this is now x is our greatest common factor here, and we're left with x minus 1. And I'm going to write a plus here for now, and we're also going to write x minus 1 because these have to match. We're going to combine them at the end. So now -2x, what times x equals -2x? It's going to be just -2. And we'll check, does -2 times -1 equal +2? It does. So we'll close those brackets. Now we're going to merge these two terms together and we'll write our x minus 1 there. And then these two terms, x minus 2 plus -2 is the same thing, it's just -2. So we're going to write x minus 2 here. Now we are multiplying those together. That's how we factor with the AC method. And the 7x cubed just goes here at the end. We don't have to write the brackets anymore because we can multiply in any order. Okay, just trying to move on to the next problem here. Let's see. Got to write the answer here, but go to the next problem. All right, so if you ever get to the end and you realize that Oh, I'm not able to factor with A times C. Nothing adds up to B. Go back and check and make sure that you've factored everything right. So that's what I did when I noticed that there was a slight error there. You might think, well, this doesn't make any sense. I listed out all of the factor pairs, and then none of them, when I add them together, equals B. That's just when you'd go back and double check everything. Okay. So I kind of think that mistake was a good thing because that is something that I believe is common when we do factoring is we get to a point where sometimes we get stuck and we can't figure out maybe what all of the what all of the options are for writing out our factor groups, or maybe they just don't exist. So we've got to go back. And then there are special cases where they don't exist and we use the quadratic formula instead of the AC method. But for now, most of these problems should all work with the AC method. So if the AC method doesn't work, go back and double check your work. Okay, let's see if we can try one more of these here. We'll do this next one. This one looks like the AC method. Um, Looks like we do the AC method twice, and I might be able to show you a shortcut for this as well. So again, all of our quadratics are in the form ax squared plus bx plus c. If we look at this first one, a is 1, b is -5, and c is equal to 4. A times c is 1 times 4, which equals 4. And we'll write all the ways to get 4. 1 times 4, 2 times 2, -1 times -4, and -2 times -2. Now, from these options, 4 options here, if we add together these factor pairs, we want them to equal -5. So the first one, 1 plus 4, that would be +5, not that one. 2 plus 2 is +4, -1, and -4. If we add those together, we get -5. So we're going to separate this -5 into a -x and a -4x. So this is x squared minus x minus 4x plus 4. And I just rewrote that out into 4 terms instead of 3. The x squared minus 9, we're going to hang on to that. I'm not even going to write it down right now because I don't want us to get confused with what's happening here. But we put parentheses around everything, put a plus between the middle. Now we find our greatest common factors in x on that first part. X minus 1 is what's left over. We're going to write the x minus 1 over here. Figure out what times x is -4x. That's -4. And then also checking to see, does -4 times -1 equal +4 when we multiply that out? So we should be able to multiply those and it equals that at the end. And it does. -4 times -1 is +4. Now we're going to merge those together. We get x minus 1. Write these separate, x minus 4, and multiply everything together. Now we're going to write the x squared minus 9 down here. Okay, we're going to do the AC method again with the x squared minus 9. Here a is 1, b is 0, and c is -9. So a times c for this part, x squared minus 9, is 1 times -9 or -9. All the ways to multiply to get -9, we just did 1 times -9, 3 times -3, and let's see, -1 times, actually, I'll write it. I like to write all the negatives on one side and all the positives on another. So we'll do 9 times -1 like that. And that's all the ways to get -9 with multiplication. So Now we want to figure out which ones of these, if we add them together, will equal b. Well, it's got to be 3 plus -3. That equals 0. So I'm going to write the x minus 4, x minus 1 down here. And now we're gonna write this as x squared plus 3x minus 3x minus 9. And I'm going to just put parentheses here and put a plus between them. I'm going to write the x minus 4, x minus 1 on the outside. And I'm just going to put brackets now because we got so much stuff going on over here. And brackets are the same thing as parentheses. But when we have double and triple parentheses, it's easier to see it with a bracket. So now we're going to find greatest common factor for this part. That's going to be x. We're left with x plus 3. Now we're also going to write x plus 3 over here. And what times x is -3x? That's going to be -3. And then double checking, does -3 times 3 equal -9? It does. So now we're going to write all this out again, and x minus 3, this goes into a binomial, and then this part, we combine it into a single binomial, and we do that because of the distributive property. I've had students ask why we do that. If we re-multiply it out, that's what we end up getting. We end up getting this part here. So that's a simplified way of explaining that. Okay, so this is our final answer for factoring this completely. Now, there is a shortcut with when we have something where there is no b value, and if it's a minus, that's called difference of squares. So difference of squares says we can find the square root of both of them and then write it out and then do one of them as a minus and one of them as a plus. So the square root of x squared is just x. The square root of 9 is 3. So then we write x plus 3 times x minus 3. And that's it for difference of squares. If we had, all right, a different one. If we had x squared minus 25, that would be x plus 5, x minus 5. So that's difference of squares. Okay, so that's our final answer for this. So we're doing the AC method for both of these now. So you have to decide for yourself what method that we're going to use. So if you ever get stuck and there's nothing else that you can do to move forward, then try a different method. Okay, so those are the methods for factoring higher degree polynomials and factoring monomials. So this is everything from Unit 3, Quiz 1.